An ideal gas at pressure P0 and volume V0 undergoes an isothermal expansion to triple its volume. The gas is then slowly and adiabatically compressed back to its original volume. Sketch a PV diagram for the processes. To sketch the PV diagram, now we prepare or construct the coordinate systems with the horizontal axis in the V volumes with the units meter cubes, and for the vertical axis it is P pressure in the unit of Pascal. It is given in the questions that the initial pressure of the gas is the P0 and the initial volumes of the gas is the V0. So now we use a point to represent this initial state of the gas with the value of the pressure P0 and the initial volumes of the gas is the V0, and we label this state as the state number 1. The gas undergoes an isothermal expansion to triple its volume. So we can now sketch a curve to represent this thermodynamic process. This curve that represents the isothermal expansions, we call it the isotherms. And this dot represents the final state after the gas completed the isothermal expansion. According to the informations given in the questions, after the isothermal expansions, the gas volume becomes 3 times of the initial volume. So that means now this state, the volume is 3 V naughts. Initial volume is V naught, so this one is 3 V naughts, and we labels this final state as the state number 2. The second process is the adiabatic compressions. So from the state number 2, should we draw a curve to the state A like this, or should we draw from the state number 2 to B in this way? Take note that both the A and the B states, the volumes is the same as the initial volumes of the gas, which is the V0. So that means this A, state 1 and state B are on the same vertical line. So now we need to know which one is correct for the adiabatic compressions, whether it is given by the curve from the state 2 to A or from the state 2 to B. Which one is correct? To know the truth, we can use the first law of thermodynamics to analyze the properties for the process of adiabatic compressions. The first law of thermodynamics is given as the Q equal to delta ETH plus W, where the Q is the heat, W is the work done by the gas, and delta ETH is the change of the internal energy of the gas. Since the second thermodynamic process that we consider in these questions is the adiabatic process, that means the Q by definitions it is equal to 0. So now we have this internal energy change equal to the negative of the work done by the gas. But because the gas is compressed, so the work done by the gas is the negative value. W itself is a negative value. So negative value of the W multiplied with a negative will have the positive value at the right hand side of this equality sign. That means the change of the internal energy of the gas should be a positive value in this process of adiabatic compressions. internal energy change of the gas relies on the temperature of the gas. So now, if the internal energy change is a positive value, that means the change of the temperature of the gas also should be the positive value. This implies that if the curve from 2 to A is correct, then the TA should be larger than T2, which is the same as the T1. Now, if this curve is correct, that means the TB should be larger than T2, which is equal to T1. But from the equations of states or ideal gas law, we know that T is equal to, temperature is equal to PV over NR, where the N is the number of mole of the gas, R is the gas constant, P is the pressure of the gas, and the V is the volumes of the gas. For these three states, state A, state 1, and state B, their volumes are the same. So this V is a constant value. R is a gas constant, also is a fixed value. N is the number of mole of the gas, also is the same for these three states. So that means the temperature for these three states, A, 1, and B, depends on the pressure. When the pressure is larger, the temperature of the corresponding states of the gas will be larger. So that means TA should be larger than T1, should be larger than TB. This is a result that we can deduce from this relationship between the temperature and the pressure when the volumes is constant. So that means the temperature at the state A is larger than temperature at the state 1, and the temperature at the state 1 is larger than the temperature at the state B. From this result, now we can determine that the curve for the adiabatic process from 2 to A is correct, because for this curve we have TA larger than T2, which is equal to T1. So TA is larger than T1. TA is larger than T1. These two are consistent. But for this curve from the 2 to B, we have this TB larger than T1, which is contradict with the result that we obtained. Here we have TA larger than T1 larger than TB. But now here we have this TB is larger than T1. So now we can confirm this curve from 2 to A is the correct sketch that represents the adiabatic compression process. Finally, we have this complete diagram that reflects the two thermodynamic process that happens on the gas we consider. Initially, the gas have the initial pressure P0 and the initial volume V0, and it undergoes the isothermal expansions to make its volumes becomes 3 times bigger compared to the initial volume. So here is a V0. Now the state number 2 becomes 3 V0 in the volume. And after that, the gas undergoes the adiabatic compressions, and its volumes change back to initial volumes. But in this process, the temperatures of the gas has to be increased. That means now the temperature for the T1 and T2 are the same because they are on the same isotherms in the isothermal process. And from 2 to 3, which is adiabatic compressions, the temperature has to be increased. So that means we have T1 same as the T2, but they are less than the temperature at the state number 3.